You're standing in a forest. No phone, no map, no trail marker. The ground in front of you shows something. A slight depression in the leaves, a bent twig, maybe a smudge in the mud. That could be a heel or could be nothing. The animal you're following left this mark somewhere between 2 and 6 hours ago. It's alive, it's moving, and it has every biological reason to not be found. You have no idea which direction it went from here, and you need to eat. This is the situation your ancestors solved. Not once, not occasionally, every single week of their lives for tens of thousands of years, across deserts and forests and open grasslands, in rain and heat and darkness. They followed animals for days, not hours, days. Across terrain with no landmarks, through weather that erased tracks, in pursuit of creatures that were faster, stronger, and far better equipped for the environment than any human had any right to be. And they didn't lose the trail. Here's what nobody explains when they talk about ancient hunting. It wasn't about being quiet. It wasn't about being fast. Modern humans can't outrun a deer. We can't outrun almost anything worth eating. A healthy impala hits 55 miles per hour. A white-tailed buck disappears into tree cover before your eyes have even registered the movement. Speed was never the human advantage. It was never going to be. What early hunters had was something stranger and, in its own way, more impressive. They could build a picture of an animal's life in their heads from almost nothing. A broken branch at shoulder height meant a specific size. Spacing between prints told them speed and gait. The direction a leaf was pushed into the mud told them which way the foot was traveling. Urine smell told them sex, stress level, proximity of other animals. Flies circling a particular spot meant something had bled there recently. Birds going suddenly quiet in one direction meant something large had just passed through. None of this is instinct. Every single piece of it is learned knowledge, passed down over generations with the same seriousness that we now pass down medicine or engineering. You didn't figure this out yourself. Someone taught you. Someone taught them. The chain goes back further than writing, further than agriculture, further than any institution humans have ever built. The question isn't whether ancient humans could track animals for days. The record is clear. They absolutely could. The question is how a human brain without a single piece of modern technology holds that much information about a living creature it cannot see across time and distance without ever losing the thread. The answer is one of the most fascinating things about our species. Here's the thing that should genuinely stop you for a second. Humans are terrible hunters by almost every biological metric that matters. We're slow. Our sense of smell is embarrassing compared to basically any predator worth naming. We can't see in the dark. We have no claws, no venom, no natural weapons of any kind. A lion doesn't need a plan. A wolf has a pack and jaws that can crush bone. An eagle can spot a mouse from 2 miles up. We have sweat glands and big foreheads. That's the opening hand evolution dealt us. And yet somehow we became the most successful hunters in the history of this planet. Not because we overcame our biological limitations, because we turned 2 of them into the most devastating predatory system that has ever existed on land. The first one is sweat. Humans have somewhere between 2 and 4 million sweat glands distributed across the body. That number is not normal. Almost no other mammal on Earth cools itself primarily through sweating the way we do. Most animals, dogs, lions, deer, cool down by panting, which means to thermoregulate, they have to stop moving. A deer running hard in summer heat hits a physiological wall. Its core temperature spikes. It has to slow down. It has to rest. It has to find shade. You don't. You can keep moving in heat that would shut down almost any 4-legged animal on the savannah. Not faster, just longer. Relentlessly, almost robotically longer. This is called persistence hunting, and it's exactly what it sounds like. You don't catch the animal by being quicker. You chase it until its body gives out while yours keeps going. The San people of the Kalahari still practice this. A hunter will follow a kudu at a jog for 4 to 8 hours through midday heat, not sprinting, just maintaining pace, until the animal collapses from heat exhaustion and can no longer stand. The second advantage is the one that made tracking possible at all. The human brain's obsessive, almost compulsive need to find patterns and build predictive models from incomplete information. Neuroscientists call it predictive processing. Your brain is not a camera recording what it sees. It's a prediction machine, constantly building models of the world, running simulations about what comes next, and updating when reality doesn't match. This is expensive cognitively. It's one of the reasons our heads are so large and our births are so dangerous. But in a tracking context, it is an almost supernatural advantage. An experienced tracker doesn't just see a footprint, they see an animal. They build a three-dimensional model of its body, its weight distribution, its speed, its stress level, its destination. They project that model forward through terrain they haven't walked yet, and they know with genuine confidence where the animal is going to be, not because they're guessing. Because the ground has been telling them a story for hours, and their brain will not stop reading it. The actual knowledge itself is where this gets almost incomprehensible in its depth. A track in soft mud is the obvious one. Everyone understands that. Animal foot, wet ground, impression left behind. A child can follow that. But experienced trackers in the Kalahari, in the Australian outback, in the forests of the Pacific Northwest, were reading things that have no equivalent in any skill modern people are taught. They were reading disturbed spider webs to establish how recently something had passed through. They were reading the behavior of dung beetles around a fresh dropping to estimate time of deposit within a window of 30 minutes. They were looking at the way morning dew had or hadn't reformed on pressed grass to determine whether a print was made before or after dawn. This is not folklore. Researchers who have spent years documenting the tracking knowledge of the San people in Botswana describe encountering information systems of staggering complexity. Louis Liebenberg, a scientist who embedded with sand trackers for decades, concluded that the cognitive demands of expert tracking are comparable to reading a scientific paper in real time. You are processing layered, ambiguous, time-sensitive data and running continuous probabilistic inference about something you cannot directly observe. It is by any serious measure a form of science. Hypothesis, evidence, revision, prediction. Birds were a critical data layer that most people never think about. Different species have different alarm calls. A tracker moving through unfamiliar terrain wasn't just watching the ground, they were listening to the canopy. Fork-tailed drongos in southern Africa give a specific call when a large terrestrial predator is nearby. That call tells you not just that something is there, but roughly what size and from which direction. Oxpeckers hitting on or suddenly departing from a specific spot in tall grass tell you there's a large mammal beneath them right now. You can triangulate position from bird behavior across hundreds of meters without ever seeing the animal directly. Smell was used in ways that seem almost implausible until you try to actually train it. A stressed animal produces different chemical compounds than a relaxed one. An animal that has been running smells different from one that has been walking. Experienced hunters could detect the specific musk of individual species at distances that should not be possible given human olfactory biology, except it isn't about raw sensitivity, it's about training. The brain learns to pull signal from noise it previously ignored entirely. And all of this knowledge, every bird call, every beetle behavior, every dew pattern, every smell, existed only in human memory. There were no textbooks, no diagrams, no written records of any kind. It was transmitted through direct teaching, through demonstration, through years of walking behind someone who knew and watching what they watched. A sand boy in the Kalahari didn't start learning to track at adolescence. He started at 3 or 4 years old, crouching next to his father over a print, being asked what he saw, being corrected gently when he was wrong. By the time he was old enough to lead a hunt, he had been accumulating this knowledge for over a decade. The information density in his head about the living world around him was something no university degree in biology comes close to matching. Not because the degree isn't rigorous, because the knowledge itself is different in kind. It is embodied, contextual, and built from thousands of hours of direct sensory contact with a specific landscape. It cannot be downloaded. It cannot be summarized. It has to be lived. Most of what we call human progress is the story of outsourcing. We outsourced memory to writing. We outsourced calculation to machines. We outsourced navigation to satellites. Every time we did it, we gained something real and lost something we didn't notice we were losing until much later. GPS is the cleanest example of what that trade looks like. Studies of London taxi drivers conducted before and after the introduction of satellite navigation showed measurable differences in hippocampal development, the part of the brain responsible for spatial memory. Drivers who learned the city the old way, spending years building a mental map, street by street, developed significantly denser neural architecture in that region. Drivers who relied on GPS from the start did not. The brain builds what it uses, it does not maintain what it doesn't need. Now scale that backward 100,000 years and think about what a persistence hunter's brain looked like. not metaphorically, literally. What was the neural architecture of someone who spent 30 years reading landscape, modeling animal behavior, listening to birds, tracking time through shadow and dew and beetle activity across dozens of square miles of terrain they knew like a language? We don't have a scan of that brain, but we know enough about neuroplasticity now to make a reasonable guess. It was not like ours. What's being lost isn't just a skill. It's a way of being present in a physical environment that modern life has made almost completely inaccessible. A tracker following an animal for 2 days isn't thinking about anything else. There is no background noise of appointments and notifications and things that need doing. There is only the ground, the air, the light, the sound, and the continuous unbroken thread of attention connecting them to an animal they cannot see. That quality of attention is its own thing. It doesn't have a clean modern name because we don't have much use for it anymore. A small number of people are trying to pull this back from the edge. Louis Liebenberg has spent decades not just documenting sand tracking knowledge, but arguing that it represents one of the earliest and most sophisticated forms of scientific reasoning ever practiced by our species. Organizations in the United States, South Africa, and Australia now run formal programs teaching traditional tracking as both a conservation tool and a cognitive practice. Tom Brown Jr. has trained thousands of people in New Jersey pine barrens using methods passed to him directly from a Lipan Apache elder named Stalking Wolf. The knowledge exists. It is being kept alive by a thin chain of people who understood what would happen if it wasn't. But here's the thing that stays with you once you understand what these hunters were actually doing. They weren't just following an animal. They were reading the world as a continuous living text, one where every element, the grass, the insects, the birds, the sky, the smell of the air at different elevations, was carrying information if you knew how to receive it. They moved through their environment in a state of total informational contact with it. Nothing was background. Everything was signal. You descended from people who could do that, not as a metaphor, directly, biologically, without interruption. The same brain that is reading these words right now was built by 100,000 years of that kind of attention. It is still capable of it. It has simply not been asked.